Compartment A and B. Compartment A and B separated by a semi-permeable membrane. Though it is semi-permeable membrane, K and Cl, potassium and chloride, both are permeable. So both ions are permeable. One side is having more potassium chloride, more potassium ion. Another side, less. Net electrical charge, 5 positive charge is this side, 5 negative charge. So net neutral, so this is neutral. This is neutral. And concentration is also same. Concentration of 5K and concentration of chloride is same. And here, this is also electroneutral. Number of positive ion, 10, number of, okay. So this is the initial condition. Now, since its concentration is higher, here, its concentration is less. So what will be happening? There is one gradient I can see, concentration gradient. So we know that when there is a concentration gradient, if partition is semi-permeable, so there no problem in coming and going. Okay? So what will happen? From higher concentration to lower concentration, diffusion will occur. How long it will be continued? When both will become same. Now, potassium ion will start migrating from this side to this side. Now see what's happening. Number of potassium ion is increasing. Chloride ion, same. When this chloride ion lost this potassium ion, some of the chloride ion became alone. They wanted to remain together, positive ion, negative ion. But because of, so there is one bonding between a boy and girl. Okay. So now what happened? Because of money or something, their money is more, less, here, so I could, not money. So he will be traveling there. Because here it is, concentration is high, so he will be migrating there. Since less concentration, leaving you alone. So their positive charge will be increasing. Here negative charge will be, it will become more negative. Now it is not neutral. So here what happens, if it moves to this side, gradually its side positivity will increase, here positivity will decrease. And one time will come, this will be 5K, this will also be, initially it was 5, no?
Yes, sir.
So how can I divide equally? 10 plus 7.5. So I do one thing. If I make it 20, 10, if 10 comes, then 10, no, 15. Yeah, 15. 15K. Now if 5 moves from this side to this side, then it will be 10. It will also be 10. Equal distribution. Equilibrium has reached. But because of its migration, what happened to this side? It became negative. And what happened to this side? It became positive. It became more positive. Okay. It is plus 5 and it is minus 5. Oh, it is neutral. 5 is moved, so it became 10. Now what will happen? Chloride ion is less here. Here is more. So here chloride ion will move to make it electroneutral. So usually again it will also be 10 minus 10 Cl. Now it is electroneutral. So after diffusion, equilibrium reaches. So number of ions, anions and cations, anion and cation remain same, and charge also remains same. Okay, neutral. It is also will become neutral during equilibrium. Now see what happens when I placed, instead of chloride ion, I placed protein negative. Okay, here it is 5 Cl. No, 10. 10 Cl. Protein cannot come to this side. Why? Insoluble. And not insoluble, impermeable. Because of this impermeable ion, presence of this impermeable ion in one side, these ions will be unequally distributed. Previously, because of absence of these sort of ions, they were equally distributed. Now, because of presence of this ion, more cations will be accumulated here, and more anions will be accumulated here. So there will be unequal distribution of ions across the membrane because of presence of one non-diffusible ions. This is Donnan effect. This is called Donnan effect. So we can see, because of presence of an insoluble ion, not insoluble, impermeable ion, there is unequal distribution of anions and cations. So Donnan effect, this is called Donnan effect, unequal distribution of ions. Number 1. We are discussing what? Why resting membrane potential develops. Why inside is minus 70 millivolt in respect to outside of the membrane. We are trying to find out the reasons. So one reason is unequal distribution of ions. Proteins are more inside. So as a result of this, there will be unequal distribution of anions and cations. So positive charge sodium ion will be more that side. Okay, here it will be less. Net charge of positive charge will be less in this side, protein side. So less positive charge ion, more negative charge ions. As a result, what will this side will be negative? This side, and since other side is having lot of relatively more positive ions than negative ions, so that side will be positive. So this is one reason of difference in charges externally and internally. More positive charge outside, less negative charge inside. More, it means it is more negative inside. So this is one reason. Unequal distribution of ions because of presence of a non-diffusible ion. Now see, this is a cell. This is ECF, and here it is within the cell. This is ICF. Okay. This is nucleus, and the nucleus is having DNA, genetic material. Means gene is there, genetic codon will be there. So, for developing resting membrane potential, what it did, it produced an mRNA. This mRNA will be translated in endoplasmic reticulum. It will, translation of mRNA will produce a protein. And these are nothing but a membrane protein. Nothing but a channel for potassium. Okay, so it developed a channel, potassium channel. Why? Because the cell could see there are more positively charged ion outside, particularly sodium ion, here more potassium ion, and more negatively charged ion. Initially it was equal, now what will happen? Here potassium ion is less, here it is more. Concentration of potassium ion inside is more, outside is less. So there is a concentration gradient. Because of this concentration gradient, here, this side is high, this side is low concentration. So it will move to this side, and this channel is such that it will not interfere. Go. It is wide open and you are little inside, pass. So as long as concentration gradient exists, so it will travel. As kotokon, how long? As long as both sides becomes equal. So what is happening? This side, inside, it is losing potassium ion, positive ion. So if there are 10 negatively charged ion, 10 positively charged ion. Okay? So if 2 moves away, before moving, there was equal in number, charges were equal. Now if 5 go away to that side, what will happen inside? What about the charges? Previously it was 0. Now since potassium has left, leaving chloride ion, what will be there? Inside will be negative. And outside, it is bringing positive side outside. Positive. So it is going because of a pressure. What pressure it is? Concentration gradient. Because of a, not pressure, force. Because of a, this is called concentration gradient. Now, if it goes to this side, what happens? This size gradually becomes gradually negative. Another force is developing here. Because of movement of the potassium from this side to that side, because of concentration gradient, here another force will be developing. Electrical force. Gradually it is becoming negative. But these ions actually tries to hold the potassium ion. They don't want to leave. They don't want to release this potassium ion. Because potassium ion and the positive ion and negative has an attraction. So, declining this attraction is favoring the movement, because concentration gradient is more important, more powerful. So it's moving, creating negativity inside. So if instead of 5, 10 goes, so it will become more negative, and time will come. It is going, that side concentration gradient is reducing. Gradient is reducing. And time will come, it will be equal. Now, here what is happening? There, that side concentration gradient is minimizing. Here, increasing. What increasing? Charges. Negativity increasing. At the time will come when both opposing forces will be equal. And because of the force, what will happen? Potassium will try, no, I don't want to remain with you. And here when it will come, here, lot of potassium, and they are not allowing entering there. So he is in dilemma. What to do? Whether to go or not to go. So there will be net diffusion 0. There will be net diffusion 0. And this is called equilibrium. This is called equilibrium. Means exit of potassium ion, there will be no exit. Though a concentration gradient is there. Why could not go? Because of this negativity. Negativity, it became such that, no, I can't release this. I want this positive valve. I will not allow. Now, initially I allowed. My force was less. Now my force is more. More negative I have become. I cannot release this. So there will not be any entry of this. At this position, at this moment, what is the potential difference? This is called the equilibrium potential. No movement of ions. This is called equilibrium potential. Okay. And this potential, how much potential has been generated in this condition? When equilibrium is reached, this is called Nernst equation, Nernst potential. What is this? This is nothing but Nernst potential is nothing but equilibrium potential. Nernst potential. How Nernst potential developed? So because started moving, inside becoming gradually negative, outside becoming more positive. So there is developing potential difference. And this potential difference, why develop? Because of diffusion of chloride ion to the side. This potential now will be increasing. This is called diffusion potential. So gradually, with the movement of potassium ion, gradually will increase the diffusion potential. And one time will come when the pulling pressure and the going pressure will remain same. That means equilibrium will be there. So at that time, the potential, diffusion potential coming to a point when both the pressure is equal. So this potential difference is called equilibrium potential or Nernst potential. Now, understood what is Nernst potential? Now you can estimate it. How much is this? You can calculate it. Okay? How you can calculate it? From an equation called Nernst equation. F plus minus RT by ZF log 10 concentration inside divided by concentration outside. This is the actual. When we solve this, the value of RT and ZF, then we get plus minus 61.5 log E. Okay, so what is R? R is gas constant. R means gas constant. In this equation, R means gas constant. T means absolute temperature. Divided by what? Z. Z is the number of charge the ion having. For potassium, number of charge? 1. Okay. And it is positive. So in that case, no plus, instead of plus minus, we will be writing plus. Okay. So then what is F? F means Faraday, 36,500 Dalton. This is the value. So if we put all this value, we find what? 61.5. So how this 61.5 came? This way came. Then the remaining part is same. Concentration of potassium ion outside, inside, and divided by concentration of inside. Then you will get a value. This value, when you solve this value on this equation, you will find a value which is minus 70, minus 90 millivolt, which is very close to resting membrane potential. So what is the, if I take the value of potassium, then this equilibrium potential is for potassium only. We considered that there is only one channel, that is for potassium. But there are channels for sodium also. Let us see what happens. We consider sodium. Sodium concentration is higher outside, inside it is less. So what will happen? Concentration gradient outside to inside. So potassium ion will start moving because of concentration gradient, will moving from that side to this side. As a result, outside will become gradually less negative and inside will become positive. So initially it was minus 70 inside.
I negative from outside.
Outside is positive.
So if Na plus coming becomes inside.
Gradually the positivity will be reducing. Positivity will be not yet negativity developed. Positivity will be reducing, and here negativity will be less because positive charge is coming. Initially it was minus 74. Now it will be minus 55, minus 60, minus 55, and ultimately it may reach to 0. But concentration gradient still there. So even further entry of sodium will be there. As a result, what will be there? Positive inside will become positive, outside will become negative. And this will continue. How long?
Equilibrium.
At equilibrium. But another force will oppose this. When it is coming forward, outside is gradually decreasing. Decreasing positivity, coming to negativity. So another force is developing there. So that the force and this two opposing force will be acting, will be equal. So there will not be any movement of sodium ion. So this is called equilibrium. We will say equilibrium for movement of sodium is reached. And during this condition, what is the potential across the membrane? That is the equilibrium potential for sodium. Okay, we can also determine this from Nernst equation. Same, put the concentration of sodium there inside and what is the concentration outside, and then simply change the value, negativity or negative or positive. So we will get a value of near about 40, plus 40. But our resting membrane potential is minus 70. So it is not the sodium ion that has created resting membrane potential. It is not the sodium. But we can say it is the potassium because its value is close to resting membrane potential. So now in the second case, for sodium, we can determine it also by Nernst equation, and we will find a value we said what is the value? Plus 40 millivolt. In this way, we can also measure the equilibrium potential for chloride ion. We get a value. Now, argument is, okay, let's see. You have sodium ion, you have contribution, she is potassium ion, she has contribution in developing resting membrane potential, she is chloride ion, she is also having some role. Okay, what is the role of three together? What is the role of all the ions together? And how can you determine this combined role? Again, there is an equation. Goldman-Hodgkin-Katz equation. This is nothing but, it's like Nernst equation for sodium, combination of Nernst equation for sodium, combination of Nernst equation for potassium, combination of Nernst equation of chloride. All these were combined, and another new thing was added, that is what? Permeability of each ion. Concentration is there in addition to what is your permeability. Let's see what is the permeability. My nucleus say, okay, problem is not solved. Let's do one thing. Let's prepare another mRNA and produce another protein, and it will create another transport, another ion channel, and that channel is sodium channel. Previously we found that there is potassium channel. Now another channel came. Understand this, the mechanism, how it is, RNP is developed. You have to understand this thing. What are these? Selective permeability of the cell membrane. So we have seen permeability of sodium, potassium is easy. They can move against, in favor of concentration gradient, and there are a lot of channels for sodium, and they are not obstructing, easy passage is there. So permeability of potassium is more. Moreover, number of potassium ion across the membrane is much more. So number of channels, number of gates, more, and no obstruction when gradient will be there, they will be easily passing. So its permeability is more. Okay, now see, one point you try to understand. What is this? Her size is less than his size. Okay? Less than his size. His potassium ion and his sodium ion. The atomic weight of sodium ion is less, and atomic weight of potassium ion is more. Okay? So it's very easy for sodium ion to pass. Size is less. And for him, it is difficult. Size is more. But what is she doing? Size is less. She is wearing a jacket. Very thick jacket. It is like that. But for her, size is like this. So while she will be traveling to this, it will be, she will feel tight. Not easy. She will like this, she will go. Difficult. Not easy permeability. Like sodium. And what is happening in his case, he is wearing a light jacket. Because of this jacket is hydration. Hydrated, there is layer. So her hydrated layer is much more. His hydrated layer is less. As a result, the effective diameter of this ion is more than this. As a consequence, she cannot travel easily. He can travel easily. Though their atomic weight is weighing more. So this is one point. See sodium ion? So this is one difficulty, problem with her only. Another problem created by the sodium gate. Isn't it? And for her, gate is narrow. So she has to pass sideways. She cannot rush in. Whereas potassium, you can easily move. So permeability of potassium is less. Number of channels, sodium channel, is also relatively very less. As a result, contribution of sodium will be relatively less. So who is more responsible for generating RNP? Is it sodium or potassium? Potassium. So we could say in Nernst equation, sodium creating plus 40, whereas it is creating
Plus 9.
plus 90, 85, 90. No, negative. Minus, it is, inside is negative, no? So it is developing minus 85 or 90 millivolt, minus 90 millivolt, very close to actual permeability, actual potential, membrane potential across the membrane. So we could see the first point. Selective permeability of the cell membrane is also responsible for resting membrane potential. Then coming the next point. What is this? Sodium-Potassium Pump. Sodium-Potassium ATPase. ये क्या हुआ? सोडियम तो निकल पड़ा. सोडियम क्यों निकल पड़ा? कैसे निकल पड़ा? वो कहाँ से कहाँ आया? बाहर से अंदर आया. बाहर से अंदर आया, है ना? इन फेवर ऑफ कॉन्सेंट्रेशन ग्रेडियंट. जैसे वो साइडवेज और वो बाई facing more difficulty, she ultimately came. But there is one guard. No, you are not allowed. How you have came, I will push you back. You came from outside, so I will push you to outside. Okay, and taking this scope, potassium also concentration more where? Inside. Potassium, because of some certain change on the membrane, some sodium ion from outside enter into the cell, and taking this scope, potassium inside is more, it went out. Then it said, no, you are not allowed. Get out. So get out करने के लिए क्या चाहिए? धक्का देना पड़ता है ना? क्या चाहिए? एनर्जी चाहिए ना? You want energy? So it will utilize ATP. So एक हाथ में वो 3 सोडियम को बाहर निकालेगा और दूसरे हाथ से 2 पोटेशियम को इधर लाएगा. So every time, if it goes on for 10 times, ultimately how many? What will be the net effect? 3 going positive charge, 2 coming. So ultimately, outside is getting more positive. For every term, 1 positive charge. Second term, another positive charge, and it is losing. So as a result, what will negativity will create inside? Isn't it? Sodium, 3 sodium is going, out of this 2 only coming. So what about others? So because of absence of that positive charge, so it will be negative. So gradually, if it goes on, gradually inside will become negative. Okay? And how much potential difference you can make with this? Only 4 millivolt. Minus 4 millivolt. Okay? And its contribution again is very less to resting membrane potential. So its role is not so much. Okay, so we could learn the role of second point. How much change it can make? Only 4 millivolt, minus 4 millivolt. So its role is again very minimum. Then what is this function? I am maintaining resting membrane potential. Difference across the membrane is minus 70 millivolt. Okay, there is some disturbance. So immediately what happened? Some sodium ion entered, some potassium went back. Immediately it will respond. Those who have entered go Those who have gone and out, come back. So again it is restoring resting membrane potential. So its main function is what? Restoring resting membrane potential, maintaining resting membrane potential. So these are the main function. Achha, why it is important to maintain negativity inside? What is the purpose? Question may come. What is the necessity?
न्यूट्रलाइज करने के लिए outer-
What was the problem if the both sides became neutral? Become neutral. Negativity inside favors protein biosynthesis. So the protein, the cell has to produce lot of proteins for different functions. So in this negative environment, there will be lot of this. If positivity is there, neutral is there, you want to make it neutral, no? So what you have to do? बाहर से तुमको पोटेशियम आयन लाना, सोडियम आयन लाना पड़ेगा, ना? As a result, what will be there inside? Number of molecules. Osmolality will be increased. Means osmotic pressure will be increased. So see, in respect to outside, if osmotic pressure is increased, it will draw water from the outside. Outside is less, having less osmotic pressure, here osmotic pressure more. We have discussed earlier. So when it is something is more, having more osmotic pressure, it will draw water. So now it will draw water from outside. As a result, cell will be inflated and burst. So for that purpose, I have to maintain. So whenever it is water will be entering, pump will be sending it back. When actually this fails, no, what happens? The cell will die. When the pump will be inoperative, the cell will die. Cerebral thrombosis. Less supply of oxygen to the brain. The cell membrane will not get a produce. Will find less oxygen. Ischemia of the arteries. Arteries are becoming squeezed. So less flow means less oxygen will be coming. Means cerebral ischemia. Less oxygen is coming. Means the cell is getting less oxygen. Means less production of ATP. Means less operation of this. Means more entry of sodium ion. Means inflation of the cell. Means dying of the cell. You find the physiology? So this is the physiological explanation. Okay? So its role I told you, and equations. Oh, this is actually how it is. In our theory class, or in during your seminar I asked you a question, what is the role of phosphorylation and dephosphorylation in active transport? I asked this question. See, what happened? Outside sodium ion is more, inside it is less. This is outside, this is inside. Here potassium ion is more, here it is less. That's why its shape is like this. So, by some means sodium entered. So I have to send them back. ATP, this is the sodium ATPase protein. They are having several peptides. These are beta unit, this is alpha unit. So beta unit is having one binding site for ATP. When it binds with ATP, immediately there is conformational change in this molecule. Here is a gate, it will open. Because of opening of this, this 3Na will be entering here and be sitting there. Okay? When they said there, ATP broken down into ADP and PI. From this side, the ATP went out and it became bound to this. And because of bound attachment of this high energy phosphate, this means high energy and this means low energy. Straight line, low energy, like any other compound. But here it is having high energy phosphate. So what will happen? This will create some conformational change in this protein. So here is the gate will open. Now what will happen? This gate also open. Now this will come out and there is another two sides for potassium ion. So potassium ion will enter and will bind to this. And since it is opened, now the 3 will be coming up. Now what will happen to this? Potassium ion is there, remain bound to there. Now what will happen? This potassium ion will be coming out from this side. Means there will be dephosphorylation. And when dephosphorylation done, there will be again conformational change in the molecule so that this gate will be opened. Now, because of opening of these two gates, these two potassium ion will be coming back. So this way, phosphorylation and dephosphorylation help transfer of sodium ion and transfer of sodium ion. Log 10 K outside divided by K inside at a millivolt, which comes to be minus 90 millivolt. And this is for sodium, plus 61 millivolt. So, relative role of developing Nernst potential. Right column. And this is the combined Goldman-Hodgkin-Katz Equation. Okay, in this way you can calculate this. Now, the main points. Why inside of cell is more negative? These are the causes. More amount of non-diffusible ion, negative ion inside. Second, positive ions from inside try to diffuse out. Permeability of cell membrane. Different permeability for different ions and role of sodium potassium. So they are contributing in the development of negativity inside. And now this is the last thing. You see how action potential is developed. Then you go to for exam.
आपको जो दिया गया ना टेस्ट पेपर में आपको किसी को दूसरा नहीं मिलेगा नीचे आपको लेंस काउंटर पे रखा हुआ है पार्ट तो ध्यान से लीजिएगा यहाँ कैपिलरिटी सेंटर पे पर लेंस नीडल सब कुछ काउंटर पे रखा हुआ है ठीक है तो पहले हफ्ता तक अपने पास रखिए पेट ठीक
Write your name here. Okay. Write your name and interest. Write your name and interest.
এখানের মধ্যে বিটি কতটা পড়েছে? দুজন। মা বিটি করব? আপনাকে আপনাকে বিটি আপনি
In this piece of paper, write your name, name of the experiment, and then your inference.
বলো দিয়ে দাও কি দেখার দরকার নেই দিয়ে দেবে
ফ্রোজেন রয়েছে এনটিডি এনটিএ
বলে আমি আজকে 6 নম্বর প্রিন্ট দিচ্ছি তো বলে দিচ্ছি
Only the inference, what you have seen, the result. Okay.
और यहाँ पे कब डालना है फर्स्ट वाला
उसके बाद each and every 30 seconds हमको ब्लड ड्रॉप्स डालना है टिल द लास्ट ब्लड ड्रॉप। उसके बाद का मैंने यहाँ पर किया था तो हुआ ही नहीं।
यहाँ पे डेट मार्क करके रखना है 120 सेकेंड में कुछ ब्लड आया है
कुछ
ऐसा नहीं जब मार्क करना है तो 120 सेकेंड में ब्लड आया
So my bleeding time was found to be 1 minute 32 seconds.
you can't be that case में to 10 minutes more than
What was the blood stock of this?
Thank you.